Hi everyone, my name is Barbara. I'm a postdoc at Swinburne University and I'm studying outflows using a multi-wavelength approach. Specifically, I'm using Gecko's data, and I'm sure you're all convinced that Gecko's is a game changer. Look at this H-alpha map, especially beans still, of this wonderful NGC 3221 galaxy. And what we've added to this Gecko's data probing the ionized gas is molecular gas observations from IRAM 30-meter telescope, and also from we've got some ALMA archive, and we've put a proposal for having more results of molecular gas observations. So stay tuned for wonderful results using Gecko's data.
As you all heard from Julia's talk before, SAMI's provided us with integral field spectroscopy for over 3,000 local galaxies. And the thing that sets SAMI apart from other surveys such as MANGA is its high spectral resolution. And so with this, we can answer questions such as, why do some star-forming galaxies, like this one here, exhibit complex line profiles, whereas others, like this one here, don't? And the short answer is it all comes down to star formation rate surface density. So what we find in SAMI is that galaxies that have higher global star formation rate surface densities are much more likely to exhibit complex line profiles than those with lower star formation rate surface densities. And on a local scale, we also find that spaxels at a fixed local star formation rate surface density that live in galaxies with higher overall star formation rate surface densities are far more likely to exhibit complex line ratios. And so our interpretation of this is basically that complex emission line profiles in star-forming galaxies are signatures of winds and diffuse ionized gas. So if you want to learn more, come and talk to me in Slack.
That was perfect timing. I want to see that from everyone. Andrew Battisti, you are up.
My sparkler is on linking IFS and multi-wavelength data, particularly for the Typhoon and Magpie surveys. I'm going to focus mainly on Typhoon because we're moving on to another Typhoon. We've heard a lot of reasons why multi-wavelength approaches are very good. Basically, we can study all the baryonic components of galaxies by doing this. Typhoon is really unique in that respect. And the reason for that is its massive field of view. So that's illustrated in the bottom panel for M83, where the field of view is several arc minutes in size. And this is crucial for comparing to low-resolution data sets like far infrared and radio. And I think Typhoon is sort of a unique survey in that respect. And so you can see all the panels are matched to the Typhoon field of view, which is the second panel. And I'll just highlight Muse, which is the purple box. So you can see just how big this is relative to the Muse. So the Typhoon survey is 44 galaxies. They're all southern sky. They span a wide range of types, so dwarf, large spirals, AGN. And the optical coverage is from basically O2 to S2, so the full optical range. And just to highlight another beautiful IFS, we saw high resolution, but this is a dwarf galaxy, NGC 3109, where you can see actually individual bubbles of the H2 region, so it's really unique. And I'm also leading a lot of efforts to do multi-wavelength stuff for Magpie, which I won't talk about because everyone else is going to talk about that and other stuff. So thank you.
Thank you, Andrew Hayden Park, ladies and gentlemen.
Hello, I'm Hejin Park, a PhD student at ANU, and I'm studying spatial resolved relation between dust abundance and metallicity with Typhoon survey. So this relation has been used to track the dust evolution efficiency of a galaxy, and I'm studying this in spatial resolved scale because the dust mass could be underestimated in a wider resolution, and dust evolution occurs in local scale. So here, I'm using the Typhoon survey with multi-wavelength data, and here's the results. So spatial resolved trend of these two parameters has a correlation between them, and a broken power law better describes the observed trend. So, and also, as galaxy consumes more gas to form stars, the DGR increases. So Typhoon data enables us to explore many other scaling relations from individual regions of galaxies. So stay tuned for the forthcoming paper about this. Thank you.
All right, our next speaker is Rongjun Huang.
So today I'm happy to share the indicator of star-forming galaxy main sequence at redshift 0.5 to 3. So if you look at the upper left panel, when you plot the star formation rate versus the stellar mass, you can see the star forming galaxy line on the sequence, which is the star forming band sequence. And the width of that distribution is the intrinsic scatter, so which represent the versatility and stochasticity in the star formation history. So we investigate a subsample of 12,000 galaxies in the cosmos field. Our result indicate that intrinsic scatter is roughly 2 times larger than the measurement uncertainty. That means the intrinsic scatter is real. So go to the lower panel, we found that the intrinsic scatter over the stellar map perform a U-shaped distribution. Our research suggests that there should be a potential connection between the intrinsic scatter and galaxy feedback mechanism. The intrinsic scatter is increasing in both low and high mass n, which are dominated by the supernova and AGN feedback. And we also compare the result with some previous study. So you can see that the distribution are a bit different, and we see it caused by the different selection criteria. 1 minute.
Thank you very much. I have Yifan Mai next on the list. Online? Very good.
My screen. So, hello everyone, my name is Yifan. My research topic is the driver of gas turbulence in magpie and semi-galaxy. Gas kinematic evolved with cosmic time, and it played an important role in galaxy evolution. In my research, I measured the intrinsic gas velocity dispersion of magpie galaxy average 0.3 and compared it to semi-galaxy average 0.05 to see the evolution of galaxy gas velocity dispersion and how it related to the galaxy property. I investigated the correlation between gas velocity dispersion and the star formation rate, stellar mass, half-life radius of H-alpha emission, and also the delta star formation rate. I find that for both semi and magpie galaxy, star formation rate surface density has the strongest correlation to the gas velocity dispersion, and also find that at fixed star formation rate surface density, magpie galaxy have higher dispersion than semi-galaxy, demonstrating that star formation feedback is not the only driver of gas turbulence. And also magpie galaxy might live in the epoch that have high gas accretion from the environment. Thanks.
Thank you, Yifan. Stefania Passanti.
So, hi, I'm a postdoc at ANU, and I'm still in the journey of understanding galaxy kinematics within the large-scale structure of the universe. So last year I showed how, taking advantage of gamma and SAMI, we can actually study the alignment between the rotation axis of a galaxy with respect to the filament within its embedded, and we found that the bulge mass was the primary parameter defining these alignments. Now, since we have a strong correlation between bulge mass and supermassive black hole, this year we ask ourselves, then what's the impact of black hole activity in these alignments between galaxy and filaments? And we study both the instantaneous AGN activity, where it has a strong link in defining the alignments of ionized gas, as well as the integrated black hole activity, which has found a strong link with the star formation quenching instead of the alignments.
Thank you, Stefania. Siona Lee.
Yeah. Hi, my name is Hona Lee. I started my PhD in ICRA UWA this year and working as a new Wallaby member. So this time I'm going to introduce the work I published last year. The ramp pressure stripping is one of the most powerful gas stripping mechanism, and this simple momentum transfer condition has been widely used to explain the condition when it happens. So is it enough to explain what is observed? So I compared the prediction and observation and found a quite good agreement, which means that the simple condition is reasonably enough in a broad sense, despite the complex gas physics. So for more information, please find the paper and please chat with me. Thank you.
Oh, yes, that's not what I was expecting either, but Takafumi, if you would like to come up, go for it.
Thanks, I'm Takafumi. As you know, star formation rate is fundamental quantity to understand galaxy evolution, which is usually estimated from the IR luminosity, that's reprocessed light. and which strongly depend on the dust temperature. Oh, and so far, the dust temperature has been practically measured for whole entire galaxy, especially unresolved SED, and we implicitly assume the temperature, dust temperature, is constant over the galaxies. But this study, we, for the first time, measure the spatially resolved dust temperature distribution, not only temperature, but also dust optical depth, dust mass, for distant high redshift quasars. And this panel for the first time. And with this kind of resolved information, we decompose dust heating energy into AGN and star formation, and also estimated star formation rate, which was 3 times lower than the previous study. So that's why we think this kind of resolved information is critical to characterize the star formation rate and dust properties. Thanks.
Okay, we got the right one.
Yeah. Hi, this is Osan, Macquarie-based first-year PhD student. I'm studying impact of cluster mergers and how they affect resident galaxies. Our main motivation is so far there is no consensus on whether these events trigger star formation or amplify the quenching mechanism already existed. In order to address this question, we use 4 semi-clusters with different dynamical states and similar masses. What have we found so far is there is no difference in global star forming fractions, but merging systems show a slightly asymmetric distribution of star forming galaxies. And whereas star-forming galaxies in relaxed system are evenly distributed throughout the cluster and mainly populate the outskirts. And we are trying to detail analysis for merging regions. Stay tuned. Thanks a lot.
All right, last one of the day.
Hi, I'm Monse from Swinburne, and this is my sparkler. Thank you.